All right, here we go. Last page of practice test 1. Draw a picture, write an equation, and solve. What does octagon mean? 8. So you're going to draw a circle. You're going to put 8 little marks around it. Going to connect those little marks. And the radius of the circle is 12. Now, yesterday I drew in all 12 of my radii. I'm not going to do that again. You can if you want. Obviously, if I drew them all in, all of my radii, there are 12. If I drew in all of the 12s, there would be 8 triangles. But I only care about 1. So tell me about this angle right here.
It's going to be 45.
How do we know that angle is 45? 360, if I drew all these in, there's 8 of them, 360 divided by 8. Kids, you got to figure that out. Okay? So what is the area of the triangle? 1/2, 12 times 12 times sine 45. So I'll just type that in, and that will be the area of the triangle. So 1/2 times 12 times sine 45. I got 50.91. Somebody else get that? Okay. That is not the answer to the question, though. You guys have to leave it free. Go ahead. How do I get the answer to the question?
You have to divide it by 8.
I don't divide it by 8.
Okay.
I multiply it by 8. Kylie.
I was close.
I have 8 of these, right? 8
Right.
times. So I have that area 8 times. So I multiply by 8. And the area of the octagon is 407.29 square inches. Okay, everybody got it? Now, I'm going to jump down to the last problem, number 4, because it is almost the same problem. What's the difference in number 4? It's a hexagon, which means 6, right? And the radius is now 14. So here's my hexagon, and the radius is 14. Same problem, just about, would you agree? So how do I find that central angle? 360 divided by 6 this time. Hexagon, 6. So 360 divided by 6, so that's a 60-degree angle there. You can do that on your calculator if you can't do it in your head, it's fine. So what's the area of the triangle? You got to start with that. The area of the triangle is 1/2, 14, 14, sine 60. 1/2 side, sine, guys, remember that? 1/2 side, sine. So here we go, 1/2, oops, turn it on, 1/2 times 14 times 14 times sine 60. I got 84.87 For the triangle, Kylie, how do I get the hexagon?
You multiply it by 6.
By 6, that's exactly right. So just hit times 6 on your calculator. And the hexagon is 509.22. Is that one inches also? Yep, square inches. Okay, good on the regular polygon problems. Okay, so now we have to do 2 and 3. And 2 and 3 involve oh my, wait. Find the length of a shorter diagonal of a rhombus. A rhombus is a parallelogram with all sides the same. So in a parallelogram, the opposite sides are the same, but this could be 16 and this could be 18. Right, in our parallelogram. But in a rhombus, they're all the same. And we want to find the shorter diagonal. So look at your picture. Is it clear to you that this would be the shorter diagonal? As opposed to that one?
Yeah.
It must tell me something else. What did I miss? Oh, the smaller angle, so that would be this angle right here is 34. Now, we're not doing area, so don't say 1/2 16 sine 34. That would give you area, but that's not what it asked me for. It asked me for this length. So I'm either going to do the law of sines or the law of cosines. What do you think? Cosines. So x squared and cosine 34. (16 squared plus 16 squared minus 2 times 16 times 16. I've done the law of cosines a little bit longer than you have, so it just kind of rolls out for me. Does anybody have a question about that setup there? That's the law of cosines setup. All right, I'll just type it in, huh? What do I have to remember to do after I get this typed in? I gotta remember the square root. Please do not forget to square root it. Somebody shout out what you got. Okay, 87.53 is right, but what does she need to do now? Square root it. You gotta square root it. Remember, Roxy, that's x squared, right? So square root it, raise it to the 0.5 power. What did you get, Roxy? 9.36. And that's centimeters. Remember to square root it, you just raise it to the 0.5, and that will square root it really quickly for you.
So when do you have glasses?
He's learned big right
Yours is great.
All right. Now it says, problem number 3 says find the area of the rhombus. So there's the picture. I'll go ahead and redraw it.
Said I would take
That's so funny.
Here's the rhombus. And I want to find that area of it.
You do the one.
So should I draw this back in again?
Can you do the 1/2?
Because that will split it into 2 triangles. And Matthew's mumbling here something about 1/2
1
side times side times sine of included angle. So here we go. The area of the triangle is 1/2 side times side times sine of included angle. Make sure you read the question carefully. This one wanted the diagonal, so we get the law of cosines. This one wants area, so we're doing area. Kylie, one more time. I got, for the area of the triangle, I got 71.58. Okay? How do I get the area of the whole
You
rhombus?
multiply it by 2.
By 2. That's it. So just times 2. And the area of the rhombus is 143.15 square centimeters. Yep.
How do you know which side would be the smaller side?
Which diagonal was the shorter one? Well, there's one diagonal. Here's the other one.
You make it up.
You need to be able to see that one of them's shorter than the other one, yeah. Now, one other thing, listen, one other thing, Creighton's a little concerned about knowing which diagonal is longer than the other one. So, one option you have is always, if this is 34, this one is 180 minus 34, which is 146. So if I draw in the short diagonal, the red diagonal, its angle is 34. If I draw in the long, the other diagonal, its angle is 146. The bigger the angle, the bigger the segment. Okay? All right, let's wrap it up. That takes care of practice test 1.
Me too.